today we have two more questions left from your exercise 10.4. And in addition to that, I'm adding two more questions from the CBSE textbook. Okay. So sometimes what board does is they take up questions from textbooks of other boards like CBSE and other states. Then they just put it there. But I thought that they put up original questions, but it's just mix and match. They took some questions from other textbooks and then just put it there. And these two questions, they are very important ones. They were already asked in the CBSE exams, and maybe it will, who knows, it will come for your exam too. So I just want to taught you all the concepts. So 10.4 question number 21. This time, the 21 and 22, they are not numerical problems anymore, and this is a proving part. So you pay attention carefully because this is going to be a little bit more difficult than the previous question because it's concept based, not calculation based. Okay. So let's try to figure out the diagram first from the question itself. Look, the question is saying a tower subtends an angle alpha. Yeah, we are seeing a new word here. Subtends. All right. An angle alpha at a point on the same level as the foot of the tower. So up to here, you just try to figure out first. A tower subtends an angle alpha. Okay, here is a tower. Here is a tower, must be standing on the ground. You have to draw the ground. Let's name the tower AB. Subtends is similar with angle of elevation. Okay. So if you look up at the top of the tower, the angle of elevation is alpha at a point on the same level as the foot of the tower. Where is the foot of the tower? Foot of the tower is here at B. Same level as foot of tower should be this level itself, isn't it? The same level as the foot of the tower is this level right here. So the tower subtends an angle alpha at a point. So on the same level as the foot of the tower, we take a certain point here. Let me put a blue dot here somewhere. So here, from this point, if you look up at the top of the tower, this angle is alpha. Or you can consider like this. At this point itself, the tower subtends an angle alpha. This angle is how much? Alpha. That's what the subtend means. All right. If you are familiar with the chapter of circle in class 8, 9, then it looks something like this. If there is a chord here and if there is a center, angle subtended by the chord to the center, what you do is you join the radius with the chords. And then this angle right here, this is the angle subtended by the chord. What chord? This chord itself. So I'm just telling you the concept of the word subtend. All right. So here is a tower right here. It subtends an angle alpha at this point. This point, let us name it as B. So how much angle is subtended by the tower? Alpha. Okay, remember drawing is important. The diagram, once you get it right, if you get it wrong, the whole question is going to be wrong. Okay, make sure you have your drawing correct. Otherwise, no marks in there, no marks whatsoever. You will get 0. Even if your calculation is correct, if the diagram is wrong, then 0 marks. And we have interpreted up to here part, this part. Now continue. And at the second point, At the second point, each meter above the first. We have taken a previous point. Here, we have taken a point P here. From this point P, we take a second point. Second point where? H meters above the first. From this point P, we go up a little higher. How high? H high. And we take another point like this. Look, the concept is like this. Here is a previous point. We go up a little higher and we take another point. The point is how high? H high. So, okay, you draw a point above the point. There is a point Q. This is the previous point. From the previous point, you go up a little higher and we take another point Q. How high? How high is this portion? H high. And what is it? Let's read the question further. At the second point, H meter above the first. From the first point, we go up H meters. The depression of the foot of the tower. The depression means angle of depression. Okay, we are looking down now from this point, from the point H meters high. We are looking down. Since it mentions depression, we are looking down. Looking down where? Of the foot of the tower. Foot of the tower is this point right here, isn't it? Point B. So from this point Q, depression, you are looking down at the foot of the tower. So the eye level is this part right here. And we are looking down at the foot of the tower like this. How much is the angle of depression? The angle of depression is beta. This is beta. So make this as beta. Okay, I'm going to explain it once again, right? If you don't understand it right now, it's fine. The depression of the foot of the tower. So we are looking down from the point Q to the foot of the tower, and the angle of depression, this angle right here, is how much? Beta. We have to prove what? So that the height of the tower is h10 alpha cot beta. Height of the tower is this part right here, isn't it? This part is how much? We have to prove h10 alpha cot beta. Okay, let me explain it from the beginning so that you will be able to digest it properly. This is a very frequented question in your board exam. So a tower subtends an angle alpha at a point on the same level as the foot of the tower. There is a point P. This tower subtends an angle alpha. At the second point, h meter above the first. This is the first point. From the point, we take another point which is h meters above. So here is another point h meters above. The depression of the foot. We are looking down at the foot of the tower like this. And the angle of depression is how much? Beta. That's it. That's what the question is saying. Okay. And we have to prove that this AB is h 10 alpha cot beta. Okay. Now, before we begin, you know that we don't want to put the angle of depression right here. We want to take it inside the right angle triangle. So, in order to take it inside a right angle triangle, we make a jet or a reverse jet shape, and we take this angle and this angle are equal because they are interior opposite. So instead of taking the beta here, we take the beta down here. This is angle beta. So let me draw it in red. This is angle beta. And another point, I'm naming this point it as C. What's our goal? Our goal is to prove that the height of the tower is this value right here, h10 alpha cot beta. So we have to find out AB. How much is AB? Right. Now what you can see is you can see two small triangles. One right angle triangle right here. Another right angle triangle right here. So you take the smaller one first. And if this angle of subtend, this subtend or depression this is involved, Sine theta and the cos theta, they are of no use because they involve hypotenuse. So we are going to use tan theta and cot theta. All right. So if I take this triangle right here, this triangle is what? BPQ. You take tan beta. Okay, we will come to that later. First of all, let's write what is what in the beginning first. What is what? In the figure, AB is what? AB is the tower. And what is P? P is a point at the same level as the foot of the ground. P is a point at the same level as the foot of the tower. Okay, now we are looking down at B from this point Q. Okay, this is already seen, and you just have to mention that PQ is how tall, PQ is H. Okay, this is whatever is drawn in the diagram we have just mentioned here. This part you don't need to mention. A tower subtends an angle alpha, or the depression of the foot of the tower is beta. You don't need to mention this in the wording itself. Okay, now let's start the calculation. Remember, our goal is to find out AB. What is AB? In order to do that, let's start from the small triangle. Why are we starting from the small triangle? Is we want to find this out. How long is this? Because this part, this PB part, this is included in the bigger triangle, right? So in order to obtain PB, we have to come to the small triangle first. This small triangle, what is the name? You look properly. PQB. In this triangle, there is an angle beta. So you have to find out tan beta. Tan beta will be what? Opposite by adjacent. Opposite is PQ, adjacent is PB. So you find out tan beta, which will be PQ by PB. So you mention the triangle first. In triangle, PQB. What angle is inside? Beta angle. Tan beta is equal to PQ divided by PB. Tan beta is equal to, since beta is not a specific value, there is no means to put in the value of tan beta. We don't know how much is tan beta in exact value, right? So PQ we know. PQ the value is how much? H. That one we are going to substitute. So PQ is H divided by PB. What is our goal? Our goal is to find out PB first. Before we come to finding out AB, we have to find out PB first. So PB comes up here, tan beta comes down here. So we will have PB, PB is equal to H by tan beta. And what you know is A by B, I can change this into A into 1 by B. Okay, don't get confused here. B by C, it can be broken down into B into 1 by C. So likewise, P by Q, I can change it into P into 1 by Q. All right, numerator, you keep it separate, and denominator, you keep it separate like this, 1 by Q. Here, this part also, I can separate this, right? I can separate it as H, numerator H, keep it separate. Tan beta, denominator, keep it separate. I can keep it like this. So H into 1 by tan beta. 1 by tan theta is, it's cot theta, right? So this 1 by tan beta, if I change this, you will get cot beta. So H, it will remain as it is. 1 by tan beta, it will remain as cot beta. So you put here H cot beta. Now we have found out PB, right? this is found out. Our goal is to find out this part, AB part, how much is it? Our goal is how much is AB. In order to find out AB, you have to look into the triangle which has AB in it. AB is in this triangle. What's the name? ABP, or you can say ABP. So you look in the bigger triangle ABP and then you find out 10 alpha in triangle ABP. So 10 alpha will be how much? Here in this triangle, you can see that there is an alpha angle right here. So the opposite is how much? Opposite is AB and adjacent is how much? PB. So 10 alpha, instead of this, we will have opposite by adjacent, remember, TOA. So we will have AB by PB. Okay, you put in the value, AB by PB. You keep 10 alpha. AB, we don't know. We have to find out AB. And how much is PB? PB, we have already found out that PB is H cot beta, right? So PB is H cot beta already. So you replace the PB with H cot beta. So put H cot beta. Okay, cross multiply. There is a 1 down here. So cross multiply. AB and 1 will be AB. And if you multiply these two, H will come first. Next, H will come first and 10 alpha next and cot beta later on. So we will have H 10 alpha cot beta. Right. What was our goal? Our goal was to show that the height of the tower is this much. Where is the tower here? Tower is AB, right? So AB, we have obtained it as H10 alpha cot beta, exactly the same, right? With this one. So the height of the tower is H10 alpha cot beta, you mentioned here. Therefore, height of tower is how much? H10 alpha cot beta. So you can say here hands shown or hands put, whatever what that the question is saying. This says question says so that, so we will say hands on here. Yeah, the trick is to get the figure right first. If you don't make the figure correctly, then no marks. No marks, incorrect calculation, whatever it is. Okay, 22. Last question from your exercise. Okay, finally trigonometry is going to be over. Right. Okay. And now let's make it a little bigger. Okay. Just slightly small. So it says, this is an easy one actually. Vertical tower stands on a horizontal plane. All right, then there's a horizontal plane right here. There is a vertical tower right here. Vertical tower, let's name it A, B. Is surmounted by a vertical flagstaff. Surmounted means you add to the top, okay? So there is a vertical tower and it is surmounted by a vertical flagstaff. So on the top, we add a flagstaff, a little flagstaff. So flagstaff, we add it, let's add it with red. This is the flagstaff part. Let's make it C. Then read the question further. At a point on the plane. So here is the plane right here. You take a point. You take a point on the plane. Let's name it as D. At a point on the plane, angle of elevation, we are looking up from the point of the bottom of the flagstaff is alpha. If we look up at the bottom of the flagstaff, the angle of elevation is alpha. And top of the flagstaff is beta. If you look up at the top of the flagstaff, the angle of elevation is beta. Okay, let's do it correctly first. If you look up at the bottom of the flagstaff, angle of elevation is alpha. If you look up at the top of the flagstaff, the angle of elevation is beta. Now, question 1, prove that the height of the tower is h 10 alpha by 10 beta minus 10 alpha. Height of the tower is which part? This part right here, isn't it? Okay, so a vertical flagstaff of height h. The flagstaff is how tall? H tall. So you mention here the height of AC is h, and we have to find out the height of the tower AB. We actually have to prove it to be this value right here. So we have to prove that the height of the tower is h 10 alpha by 10 beta minus 10 alpha. Easy, simple if angle of elevation depression involve 10 theta, right? So there is a small triangle right here. There is a bigger triangle right here. What is common in both of them? In this triangle and in this triangle. What is common? This part right here is common, BD. Okay, you take the small triangle and you find out BD first. We will use that value here and we will find out this whole part. How tall is this part? And then we can find out AB. How to find out AB? AB is this part right here. How to find this out? From this whole part, if I cut off this part right here, from this whole part, if I cut off this part right here, then we will obtain the height of the tower. Right. But we don't know this whole part. We don't know this. But we know this. We know this to be h. This value is h. We don't know this part. So we are going to find out this part first. And in order to do that, we have to find out this part first. BD first, we are going to, our strategy will work like this. We have to find out BD first. You take this small triangle and you find out BD first. And then we will use that in here. Okay. All right, then. Let's see. Let's start. Solution. What is what first? You have to mention it. AB is the tower, right? AB is the tower. Where is the flagstaff part? AC is the flagstaff. And how tall is the flagstaff? AC is equal to H. Start taking the small triangle. Small right angle triangle is this part right here. What angle is there? Alpha, not beta. Okay, beta is the bigger one. So in this part, we have the angle alpha. And when you find out 10 alpha, it will be opposite by what happened? What happened? We have to find out 10 alpha by dividing opposite and the adjacent. Opposite is this part right here, AB. Adjacent is this part right here, BD. So find out 10 alpha in triangle. The smaller one actually ABD. 10 alpha will be how much? Opposite is AB, right? Opposite of alpha is AB. Adjacent is what? Adjacent is this part right here, BD. And as I've told you all, we want to find out BD. So BD will be AB by 10 alpha. 10 alpha and BD, we exchange places. If it comes on this side, it becomes numerator. 10 alpha was numerator. If it comes to the other side, it becomes denominator. So we exchange 10 alpha and BD is AB by 10 alpha. Let's make it as equation number 1. You go to the bigger triangle. In triangle, BDC, bigger one. In the bigger one, how much is the angle? This is beta. And if I want to find out tan beta, it will be opposite by adjacent. Opposite is this one. Adjacent is this one. Right. This one is the adjacent. This one is the opposite. So in triangle BDC, what we can see is tan beta. It will be opposite by adjacent. Opposite is BC divided by adjacent is BD. So tan beta, keep it as it is. BC, we are going to break it down. BC is the very long portion right here. We will break it down into two parts. This part right here and this part right here. So BC, we will put it as H plus AB. You can see, right? This part is H, this part is AB. We don't know the AB exact value, but we know that this part here is H. And BD, you can use equation number 1 and then put instead of BD, you can put this whole portion right here, AB by tan alpha. You can put it down here, AB by tan alpha down here. So instead of writing BD, we will write AB by tan alpha. Okay then. Let's do cross multiplication. Okay. Cross multiplication is, first of all, what we had was, we had tan beta is equal to H plus AB by tan alpha. In this position, we have 1, 2, 3. 3 labels. We want to reduce it to 2, just denominator and numerator. Tan alpha will go above. Tan alpha is going to go above. So tan beta, keep it. And we will have tan alpha above. So tan alpha will be multiplying the numerator. And what is remaining, if tan alpha goes above, AB is remaining, right? Denominator. Okay, we want AB. What we want was, we want AB. This has turned out really long. Let's rub it off. Don't want to calculate like this. Okay, just put in the value of BD. BD is AB by tan alpha, right? So tan beta is equal to BC by, instead of BD, we are going to put AB by tan alpha. Tan alpha goes above, so we will have tan beta is equal to BC tan alpha divided by AB. Now let's do a little cross multiplication. There is one numerator here, right? So cross multiply, we will have BC tan alpha on one side and AB tan beta on one side. Remember, we wanted to find out this portion right here. The previous method also works, but it's going to be a little long. That's what I'm deviating to another way. So you find out BC. BC, you can find out easily. Tan alpha, you just have to take it away to the other side, right? So find out BC. BC will be AB tan beta by tan alpha. What is our goal actually? Our goal is to find out the height of the tower, right? Height of the tower, we have to prove it to be this one. Height of the tower is actually AB. Our goal is to find out AB. How to find out AB? From this whole part right here, we will subtract this part, isn't it? Whole part we have found out. We have found out the whole part to be this part right here. Okay, so copy up to here. We have ran out of space. So copy up to here first. Okay, I'm rubbing it off. All right, or we wanted, I think it will be a little disturbing with the noise. Okay, but there is no way. It's raining heavily also. So we wanted to find out AB actually. How to find out AB? As I've been saying, you have to subtract this part and this part. So in order to find out AB, we have to subtract BC and the AC. BC we have found out to be this portion right here. AB 10 beta by 10 alpha, right? AB 10 beta by 10 alpha minus there is an H here. AC is H, right? Okay. Important thing is here is an AB stuck also. You have to put together the two ABs on one side and then you have to find out the AB correctly. So in order to do that, let's bring H to this side. There is an AB on the left hand side. You have to bring the AB to this side, H to this side, and then you take common factor of the AB. Here it will happen like this. H is brought here, it becomes positive. AB 10 beta is there, divided by 10 alpha, and there is a minus AB. H and AB, they just exchange places. Minus becomes plus, the plus becomes minus. All right, so in this two right here, AB can be taken as common factor. What is remaining? 10 beta by 10 alpha on 1, and there is a 1 here. So you combine this part, you combine these two, so it will look like this. AB 10 beta minus 10 alpha divided by 10 alpha. There is a 1 here. If you multiply 10 alpha and 1, we obtain 10 alpha. And if you cross multiply, we get 10 beta first and then 10 alpha next. Right. Okay, so what is on the right left hand side? There is H in there. One moment. So I'm rubbing off the wait a minute. Some problem. And let me rub off the other side, the right hand portion here. This part, let me rub it off. If I want to obtain the AB, this 10 alpha will come up. This 10 beta minus 10 alpha, it will come down. Right, it's cross multiplication, just simple cross multiplication. So 10 alpha will go up, 10 beta minus 10 alpha will go down. Only AB part will be remaining. So we will have H 10 alpha above divided by 10 beta minus 10 alpha in the numerator. What is AB exactly? AB is the height of the tower, right? So height of the tower is this part. We also able to obtain this part, right? So you say here, therefore, height of the tower is how much? H 10 alpha by 10 beta minus 10 alpha. We have proven what the question wanted, right? So you just say here, hence proof. Okay, any question? Any question so far? This is just simple algebra. Okay, the trigonometry part was already over. 10 alpha, 10 beta part, that's the only part that you need to understand from the trigonometry part. The others is just common sense. Common sense and a little bit algebra. Right? This cross multiplication and stuff, they are just algebra. All right, then your exercise is over. So I'm taking up two more questions from the CPSC as I've said earlier. I'm going to do the first one. The second one I'll let you all copy, but this is for your assignment just to see if you are able to understand and apply the concepts of height and distance to any other question. So I'm taking up the question on this one. So question says from the top of a building 15-meter high, the angle of elevation of the top of a tower is found to be 30 degrees. From the top of a building 15-meter high, there is a building, right? So there is a ground and there is a building. And this building is how high? 15-meter high. The angle of elevation of the top of a tower. So from this building, we are looking up. Okay, we are looking up to the top of a tower. There is a tower on the side. We are looking up to the tower. So there must be a horizontal line here. Angle of elevation is how much? 30 degrees. Then from the bottom of the same building. So from this building, this is the building, this is a tower. Okay, this is the tower, and this is the building. The question says from the bottom of the same building, from the bottom part, the angle of elevation of the top of the tower, and we are looking up to the top of the tower again. Okay, we are looking up to the top of the tower again, and we found this to be 60 degrees. Question 1, find the height of the tower and distance between the tower and the building. We want how tall is this height of the tower? Distance between the tower and the building. Distance between the tower and the building. How much is this? How much is the tower? How much is the distance between them? So you name them. This is AB. This is CD. Let's make it as E. So you mentioned here uh, solution. What is the building? AB is equal to 15 meter is the building. What else? This CD is the tower, right? CD is the tower. Now, the angle of elevation, you don't need to mention. What is the question one? We want the height of the tower. Height of the tower, this part. And distance between the tower and building, this part right here. Okay, so, so you can start here in the small one and move on to the bigger one. So let's start with the small part right here. Here with the smaller triangle right here. In triangle ACE. So this is angle of elevation. Angle of elevation question we will use 10. 1030 is how much? Opposite by adjacent. Opposite is CE. Adjacent is AE. We don't know CE or AE. We don't know any of them. So the right hand side part we will keep it as it is. Just keep it. 1030 degree we are going to change it into 1 by root 3. We know the value of 1030, right? So CE divided by AE. Keeping in mind that we want to find out this and this are equal, actually BD and AE are equal. So keeping in mind that we want to find out BD or EE. So AE, you find it out from here by cross multiplication. So we are going to have AE is equal to CE root 3. Okay, so this is question number 1. Few, once we are done with the smaller triangle, this one, we will move on to the bigger one. This triangle, bigger one right here. CBD, or you can say BCD. So move on to the bigger one in triangle BCD. 1060 degree, right? It equal to opposite by adjacent. Opposite will be CD, adjacent will be BD. CD, you can break it down into two parts. This part and this part right here. So CE plus ED. So CD is broken down 1060. I can put it root over 3. CD, you break it down. The CD part right here, you break it down into CE plus ED. CE plus ED. But what about the BD? Do we know BD? No, we don't, but we know AE. And as we have done so much before, this is a rectangle actually. And this part right here should be equal with this part right here. Opposite sides of a rectangle. So AE should be equal to BD. So instead of writing BD, I can replace it with AE. You mentioned here why AE is equal to BD. And instead of writing, sorry, instead of writing AE, I can replace it with CE root 3. Right. Okay, so CE root 3, instead of writing AE, I can replace it with CE root 3. So root 3 is equal to CE, we don't know. ED, do we know? Yes, ED we know because ED is equal to AB part. And AB is mentioned to be 15 meter. So CE, you keep it. ED, you have to put it as 15. AE, we are going to use equation 1 and replace it with CE root over 3. Okay, for this one, you have to copy the question and solution also because this is not on your textbook. Okay, we have ran out of space. We have some 2-3 more steps that we need to do. You copy up to here first. Okay, so a little cross multiplication from here. I'm going to keep this. So equation number 1, let me retain this. And this part right here, we are going to need this. Okay, when you copy from the next step. So here, if I do cross multiplication, look, if I do cross multiplication, then root 3 and CE root 3 will multiply. So we will have CE root 3 multiply with root 3. This part and this part on multiplication, we are going to get this. Root 3 into root 3, we are going to get 3, right? So 3 CE actually, if you multiply these two, we are going to get 3 CE. Root 3 into root 3 is 3, right? And CE plus 15 on other side. And now look, 3 CE minus CE is equal to 15. If I bring one of the CEs to the other side. And look, if I want to find out the CE, this 3 CE minus CE is how much? It's 2 CE, isn't it? So 2 CE is equal to 15. CE is equal to how much? 15 divided by 2. CE is 15 by 2, which is 7.5. C is this part right here, isn't it? This is 7.5. And this part is how much? This part is 15, as you can see from this side right here. So if I want to find out this whole portion CD, I have to break it down into two parts, CE plus ED. So CD, it will be CE plus ED. The CE part will be 7.5. And the ED part will be how much? ED part is already given. Actually, the AB, the height of the building is given as 15. So ED part will also be 15. Right, so 7.5 plus 15, so 15.0 and 7.5, 0.0 and 0.5 will be 0.5, and we will obtain 22.5 to be exact. So 22.5. So what you can say is the CD is the height of the tower, right? From the question, it says height of the tower, it asks the height of the tower, and height of the tower should be 22.5 meters. Therefore, height of the tower is, this is how much? 22.5 meter. And one more thing is remaining, this AE, the distance between the tower and the distance between the building and the tower. This part actually AE or BD, same value, right? So distance between the tower and the building, let me do it on the side. Distance between tower and building. Tower and building is AE. Distance between them is AE also equal to BD. And as you can see from equation number 1, the value of AE is CE root 3. So the value of BD must also be the same. We will have CE root 3 still, right? So CE root 3. The value of C is how much? We have already found out to be 7.5. So you put CE as 7.5 here. We will have 7.5 root 3. So we have found out the height of the building. No, sorry, height of the tower. Building is this one. Height of the tower we have found out to be 22.5. And the distance between the tower and building to be 7.5 root over 3. Okay, this is the end of the question. You just copy this and let's finish for today. You have to copy from here. Okay, these two are already done and I'm just keeping them for reference. All right, then I'll give you all some time to copy this question right here, this one. And this one I'm giving all as assignment. You try to apply the concepts of height and distance in there. And whoever pays proper attention to the class, they're going to get good grades, good marks. And whoever is pretending to be attending the class online, I don't think your class 10 result is going to look very good at all.